All right, so this is probabilities with replacements, right? So what we get in this problem, we have a urn that having 7 white balls and 8 black. All right. So what we're going to be doing, we're going to select 6 randomly, 6 random balls. However, every time we select a ball, we're going to note the color and then return it to the urn, right? So every time, if you select a black one, you're going to select it, you're going to note it's a black and then turn it back. If you select a white, it's the same thing. You're going to notice a white and then you turn it back and then you proceed with the second one, right? And so forth. So the question is, what is the probability that you're going to select 6 balls and they're going to be all black? All right. So now there's different ways to do this. We can proceed with the multiplication principles. All right. So here the multiplication principle is we are having 6 trials. So 1, 2, 3, 1, 2, 3. They are the 6 trials. Let's move the urn a little bit higher. Okay. And then what's going to happen here? That for the first selection, and you want a black, right? So remember, you're selecting a black ball you want, right? So what are the chances of selecting a black ball out of this? We have 8 chances out of the total, which is 8 plus 7, and that can be 15. Now, whatever the outcomes is, we're going to return the ball, and the chances for the second trial, it can be the same thing, 8 black and over 15. And so forth. It's going to be the same outcome for the third, the fourth, and the fifth and the sixth, right? And so then what will be your probability? The probability would be equals, according to the multiplication principle, it's going to be 8 out of 15 multiplied 6 times by itself, so exponent 6, and that should be, so let's see here. Oh, well, the calculation is already there. So 8 divided by 15 exponent 6, and that's going to be equals to 0.023. And you want to round 3 decimal places, so this should be your answer. Now, this is actually the long way. So let's see, there is a different way that could be faster. So the thing is, whether you're going to select a black or white is a binomial probability, right? So what is the binomial probability is always having a selection between two things, right? So here, what is the chances of selecting a black ball? It's going to be P equals to 8 out of 15. Now, what is the number of the total trials is going to be 6. So n is the number of total trials, which is 6. And the r for this is going to be as well 6, because that's the number of successful trials. Whenever we say successful, it means you are selecting this probability, which is 8 over 15, what the successful trials getting a black ball. And that's, it happens to be 6. And we are allowed to have r and n equals to 6 and 6, right? So now, once I figure out it is a binomial probability, I can go ahead and use the calculator. And how can I do that? Is by using the distributions. You see it over here above the bars. So I'm going to go second and vars. And then I'm going to get a list of distributions. So you are concerned about binomial distribution. And it happened there are 2 types of binomial. One is binomial PDF and the other one binomial CDF. So CDF stands for cumulative distribution function. And what you are using, when you're going to use the CDF, you use it whenever there is inequality, all right, less than 6 or less or equal than 6. However, this is equal sign only, so you're going to be using the PDF. Every time you have exactly equals to 6, we are talking about the R again, so it will be a binomial PDF. All right, so let's start it. So here is already filled up. So the number of trials, that the n is 6. The p is the probability, which is 8 out of 15, which is this one, the probability of having a black ball. And the x value is the number of successful trials, which is the r. All right, so you're gonna type 6 there and you're gonna paste it and enter. So this is gonna give you exactly the same probability. All right, and I hope this is easier way to solve this problem.